The objective of this video is to learn how to calculate the molecular mass or molecular weight in a formula. And also we will learn how to convert grams into moles and moles into grams. But first, we need to understand what a mole is. A mole is a chemical unit that shows us the quantity of particles that can be found in exactly 12 grams of carbon-12. But it is a reference. Nowadays, we know that this quantity of atoms can be found in a mole of any particle of any compound or any formula. Finally, this big number is known as Avogadro's number. And as you can see, this is a very, very large number because we need to move this point 23 spaces from the 6. So if you asking how many particles can be in one mole, you can find that this is the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 20, 21, 22, 23. Look, this is the amount of particles that can be found in any formula. But how can I calculate the molecular mass in a formula? Well, I need to make the addition of the mass of each atom, which is the constituent of that formula. Look at this. Let's say we want to calculate the molecular mass for water. First of all, we need the formula. You know this is H2O. This little number in here is a subscript, and it shows the amount of atoms of the element which is before the subscript. I mean, there are 2 hydrogens and 1 oxygen. We usually don't write number 1 in here. In chemistry, we don't write the 1 in here, but it means we have 1 oxygen and 2 hydrogens. Now, we need the atomic weight for each of these compounds. You have in your hand a periodic table, or you need a periodic table. You have it here. So if we are calculating this molecular weight for water, we need to find hydrogen, which is in here, and we need to find oxygen, which is in here. And now I'm going to move this a little bit, and I have these big boxes in front of you because the data I need is the atomic weight of each of these. See what I'm going to do. By this time, you will always need your calculator on hand to do all these mathematical operations. I will write the formula, which is H2O. And now I write at hydrogen, I have 2 atoms, remember, is this subscript. And for oxygen, I have 1 atom, which is this one. Then I need to multiply each of these values by the atomic mass I showed you before. For hydrogen, it is 1.00794. We are going to round these numbers to make it easier. So let's say if after the point you find 0.5 or above, you will round the number to the next one. If it is 0.5 0.4 or below, you will round to the lower name. For hydrogen, we have 1.00794. It means we round it as 1. Hydrogen is 2 atoms of hydrogen times 1. This one comes from the atomic mass in here, equals 2. For oxygen, we have 1 atom multiplied by 16. This 16, remember, comes from rounding this atomic mass. It equals 16. Now we do the addition. It gives us 18 grams. It means we have 18 grams of water for every mole of water. Let's do another example. Let's do it for sodium chloride. How many atoms of sodium do you see? There is only 1. How many atoms of chlorine do you see? There is only 1 again. Remember to multiply this number by the atomic mass, already rounded. Sodium has 22.99. We will round it as 23. And the chlorine value will be 35. 23 times 1 and 35 times 1. Then we do the addition and it is 58 grams in every mole of sodium chloride. If I ask you how many grams of sodium chloride can you find in 1 mole, the answer will be there are 58 grams in every mole of sodium chloride. And here, the question is, how many moles can be found in 150 grams of hydrobromic acid? Again, we need the formula, the correct formula. And first of all, I need to determine the molecular weight, the same time I did it before. This formula has 1 hydrogen and 1 bromine. Let's multiply this number by the atomic weight. And now, of course, you remember this cross proportion rule we already studied. So I can say that I will find in 1 mole of hydrobromic acid, there are 82 grams. Now the question is how many moles, I don't know how many moles of hydrobromic acid can be found in 150 grams of the same substance. Remember, we need to multiply the cross values, which is this 1 and this 150, and then divide it by 82. So 150 divided by 82 gives us a final result of 1.82 what? Moles or grams? Remember, we have the grams in the same column and moles in the same column again. And our X number is in moles, so 1.82 moles, and then I circle the correct answer. It is not that difficult. Now the question is how many grams are present in 2.5 moles of sulfuric acid. Let's do it together again. Sulfuric acid formula. It means we have 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. Now we know that hydrogen has 1 gram, sulfur has 32, and oxygen is 16. Let's do the multiplying. Then let's do the addition. 62 add 32 and 2. It is 98 grams in every mole of sulfuric acid. In 1 mole of sulfuric acid, we find 98 grams. In 2, the question is, in 2.5 moles, how many grams can I find? Again, look for the cross numbers and multiply them, and then divide it by the other one. So, 2.5 times 98, the result is 245 grams of sulfuric acid. And now you need to round it. Remember, now it's your turn to do your own exercises.